Today we're going to talk about some physics. In particular, we're going to talk about Newton's second law, and that's also known as F equals ma. F equals ma is probably the most known equation in physics, that one, and probably E equals mc squared. So what does F equals ma mean? It means that if we apply a force F to a mass m, we have an resulting acceleration a. So the first problem we're going to do is a problem with an inclined plane, and we'll start with the inclined plane being frictionless. And let's read the problem. It says a 50 kilogram mass is placed on a frictionless inclined plane, or frictionless incline, that makes an angle of 30 degrees with respect to the horizontal. Find its acceleration. So the first thing I always want to do is make a graph, a drawing of what's going on. So let's draw an inclined plane right here. It has an angle, theta equals to 30 degrees. And let's place a mass on the inclined plane. There, the mass is equal to 50 kilograms. And we want to find the acceleration of that mass. So A equals is what we're looking for. All right. Since we have the equation F equals ma, and we solved the equation for A, so we divide both sides by m. So we end up, and if I flip the equation around, we get acceleration therefore is equal to F over m. So what we need then is we need to find the force that acts on this object, and we divide that force by m, and we'll get the resulting acceleration. So what is the force? Well, let's figure that out by drawing the force vectors. So the first one we can think of is the force of gravity pulling down on the object. So the force of gravity is equal to mg. And since it's on an inclined plane, we want to divide that component of the force into its perpendicular component, the component that's perpendicular to the inclined plane, and the component that's parallel to the inclined plane. You can see that if you add this component and this component together, you'll end up with this component again. The angle between the vertical component and the component that's perpendicular to the inclined plane, theta, is the same as this angle right here, theta. So this is also 30 degrees. And therefore, that makes this component equal to mg times the cosine of theta, because it's adjacent to the hypotenuse of the triangle. If you make a triangle out of that, you can see that here's the right angle, and this angle here, this side is adjacent to this angle right there. So it's mg cosine theta. That makes this component mg sine theta. Now we have one more force here. Since the object is resting on the inclined plane, pushing down the inclined plane, Newton's third law tells us that there's an equal and opposite force pushing back, so there'll be a force pushing back in this direction, and so that would be what we call the normal force pushing back. Notice that these are equal and opposite in direction. That means that those two components cancel out, and this is the only component left. This is the net force, so we can write F net is equal to mg sine theta, and it's directed down the incline. And that's the force, the net force, and we can call this a net force, that will cause acceleration of the mass. So we can now say that the acceleration A is equal to the net force, which is mg times the sine of theta, divided by the mass of the object m. Notice that the masses cancel out. And we can see that then A is equal to g, which is acceleration due to gravity, times the sine of the angle theta. So g is a 9.8 meters per second squared. And the sine of theta is now the sine of 30 degrees. The sine of 30 degrees, that's 1/2. So this is equal to 9.8 meters per second squared times 1/2. And so this is equal to 4.9 meters per second squared. And that is the acceleration of the mass on that inclined plane. All right, now let's do one like this. This time, we'll get rid of the no friction and see how that changes things.